Good morning, students. I am Dr. K. Vanitha Bharathi, Department of Chemistry, Valladolid College for Women, Erode. Today, I am going to take a new topic that is very interesting topic, polymers. Today, what I am going to talk is polymer basic concepts classification, biodegradable polymers, conducting polymers, and finally applications of polymers. First, let us see what are polymers. Polymer is a macromolecule with high molecular masses made from many small molecules called monomers. This process is known as polymerization. More number of monomers which are combined together to form a macromolecule, that is known as polymers. For example, you can take ethylene which undergoes polymerization, it forms polyethylene. Here ethylene is the monomer, polyethylene is the polymer. Another example, styrene undergoes free radical vinyl polymerization, it forms polystyrene. Here, low molecular weight polymers are also obtained, comprising a small number of repeating units. That type of polymers are called as oligomers. Due to unique properties, easy processing, high resistance to chemicals, it is widely used in industrial, engineering materials and medicinal fields. Next, let us move on to degree of polymerization. What is degree of polymerization? Degree of polymerization is defined as the number of repeating units, that is monomer units, which is present in the polymer. It is calculated by the ratio of molecular weight of polymer and molecular weight of repeating unit. You can see the formula degree of polymerization, which is equal to mW divided by MO. And degree of polymerization we can calculate by using two ways. One is number average molecular weight, another one is weight average molecular weight. Higher the degree of polymerization, for better mechanical properties. As chain length increases, mechanical properties such as ductility, tensile strength and hardness rises sharply and eventually level off. You can see the picture here. Here the mechanical property slowly increases and finally it is remains constant. And the viscosity of polymer at a given temperature rises rapidly with increasing degree of polymerization. Next, let us move on to classification. Polymers are classified into various ways. First, let us see about classification based on source. Based on source, polymers are classified into two types. One is natural polymers, another one is synthetic polymers. Natural polymers which are obtained by natural source. Here you can see the example: starch, cellulose, proteins, natural rubber. Whereas in the case of synthetic polymers, these are the polymers which are obtained by laboratory techniques. That is, these are prepared by artificially. Okay. So, example here you can see polyethylene, PVC, bakelite, nylon, synthetic rubbers. Next, let us see classification based on monomer, that is repeating units what we are used during the polymerization. Under this classification we can see two types. One is homopolymer, next one is copolymer. Here homopolymer, these are the polymer which consist of identical monomers, which is same monomers. For example, if you take vinyl chloride, it undergoes polymerization, it produces polyvinyl chloride. In this polyvinyl chloride, the same repeated unit, that is vinyl chloride, is used. Whereas in the case of copolymers, it consists of different monomers. That is, you can see the example here, nylon. Here the adipic acid and hexamethylene diamine undergoes polymerization, it produces nylon 6,6. Here adipic acid is one monomer, another monomer is hexamethylene diamine. So, copolymers are which consisting different monomers. Next, very important classification, it is based on polymerization. Here you can see two types of polymerization. One is addition polymerization. Next one is condensation polymerization. In addition polymerization, monomers react to form a polymer without the formation of byproducts. There is no removal of byproducts. And usually this kind of addition polymerization takes place in the presence of catalyst. Example, polyethylene, Teflon, polystyrene, PVC. You can see the reaction tetrafluoroethylene undergoes polymerization in the presence of catalyst. Under high pressure, Teflon is produced. Next one, condensation polymerization. Here the monomers react with each other to form large structural units with the releasing of byproducts. Whereas in the case of addition polymerization, there is no byproducts. But in the case of condensation polymerization, byproducts is removed. What are the byproducts here? It is removed. Water, methanol, etc. For example, proteins, polyester, polyamides are examples for condensation polymerization. Next, as of now, we have discussed about classification based on source, based on polymerization, based on monomer. Now let us see what are biodegradable polymers. Polymers whose chemical and physical properties undergo deterioration and completely degrade when exposed to microorganisms through aerobic and anaerobic process. That is the deterioration of polymer by microorganism. That is known as biodegradable polymers. Example, albumin, collagen, gelatin, starch, polyglycolic acid, polyhydroxybutyrate. Why we are choosing biodegradable polymers nowadays? Because these are non-toxic, eco-friendly and easy to fabricate, less expensive, and it will not pollute the environment. Another next interesting type of polymer is known as conducting polymers. Conducting polymers are a special class of polymeric materials with electronic and ionic conductivity. The first invented conducting polymer is polyacetylene, which is discovered by Heger, McDermott, Shirakawa. They got Nobel Prize in 2000 for this new innovation. Conducting polymers are classified into two types. One is intrinsically conducting polymers. Example, polyacetylene, polyaniline, polypyrrole. Here, these type of polymers, that is intrinsically conducting polymers, is having conductivity in pure state. Whereas in the case of extrinsically conducting polymers, these are in this category we are adding some additives like carbon black, metal fibers. In that way, we call it as impure state of conducting polymers. What are the uses of conducting polymers? Here you can see artificial muscles, fabrication of electronic device, solar energy conversion, rechargeable batteries, and sensors. So in this devices we can use conducting polymers. Next, let us move on to real life applications of polymers. See, polymers are widely used in various ways. Here, some of the examples I have given here. Polypropylene, which are used as textiles, packaging, stationery, plastics, aircraft, construction, ropes, toys, etc. And polystyrene, it is actively used in the packaging industry like bottles, toys, containers, trays, disposable glasses and plates. And of course, polystyrene, which is also used as an insulator. Next, coming to polyvinyl chloride, you are familiar with that. Polyvinyl chloride, it is used in manufacture of pipes, isn't it? So it is also used as an insulator in the electric cables. Polyvinyl chloride is used in clothing and furniture. It is also used in vinyl flooring. Next one is urea formaldehyde resins, which are used for making adhesives, molds, laminated sheets, unbreakable containers. Next one is glyptol. It is also one kind of resin. It is used for making paints, coatings and lacquers. Next one is bakelite. This is also known as phenol formaldehyde resin, which is used for making electrical switches, kitchen products, toys, jewelry, firearms, insulators, computer disk, etc. So with this, let me conclude my part. As of now, we have discussed about basic concepts of polymer, classification of polymer, and real life applications of polymer. Finally, I just want to convey the message: you should follow 3 R's, then only we can make green environment. What is that? Reduce, reuse, recycle. Then only we can get a good environment. Thank you.